Welcome to DEEPLIZARD. My name's Chris. In this episode, we're going to pick up where we left off last time, looking at data normalization, only this time, instead of writing the code, we're going to be debugging the code, and specifically, we're going to be debugging down into the PyTorch source code to see exactly what's going on when we normalize a dataset. So I'm here in Visual Studio Code, and before we start debugging, I just want to give you a quick overview of the program here that I've written that's going to allow us to step in and see the normalization of the dataset, or see exactly how it's done underneath the hood in PyTorch. So I have here my imports, and these are the most basic imports that we're going to need to actually get this done. So the two primary ones are Torch and Torch Vision. Then we're getting transforms out of Torch Vision. We're getting the neural network package out of PyTorch or out of Torch or PyTorch. Then we are getting the data loader class so we can load our data. Next, as we discussed in the last video, we have got the mean and standard deviation values. Now, instead of having to calculate these, I just pulled these and hard-coded them into the program here. And this is kind of the same thing that you would do if we were to snag these values offline. So I didn't want to have to go through the trouble of recalculating these values. So I'm hard coding them here. We have the mean and standard deviation, and we know that we need both of these values to be able to normalize every member or every pixel of our data set. Next, we initialize our train set using the fashion MNIST class constructor. And the key point to notice here, or to take note of, is the transforms. So we have a composition of transforms. The first one is to transform our PIL image into a tensor, and then the next transform is the call to normalize, which is going to normalize our data for us. And then down here where we have the two breakpoints that I've put into place, we have the data loader constructor, where we're specifying a batch size of 1 and we're passing in our training set. And then we are passing the loader into the iter function to get an iterator that we will then pass into the call to next to get the next value from the iterator. And that next value is going to be a label and a tensor. It's really going to be a tuple that contains our tensor image and our label. So we can unpack it in this way using kind of double initializing these variables. So we're initializing the image and the label both at the same time. All right, so now we're ready to actually debug. So to debug, I'm gonna go ahead and just make sure that I have my Python run configuration selected, and then I'm going to click Start Debugging. And our breakpoint has been hit and pause the execution of this program. So now I'm gonna hit KZ on my keyboard to launch us into a view that basically blocks out kind of everything else that kind of the IDE has that could be distracting us, so we can just focus on this source code. I can't remember what this view is called. Let me actually, if we go to view, let's see, KZ Zen Mode. I think, yeah, KZ Zen Mode. So I often use Zen Mode. And you can even kind of like position the code wherever you want, but anyways, let's keep on moving here. So I'm going to be using F10 to step over and F11 to step into on my keyboard. So we'll go ahead and step into this code, and we can see now that we've stepped down into the data loader class. So this is dataloader.py, and it exists inside of Torch. So we're in PyTorch source code at this point. Now, there's not much that I think I want to show you inside the constructor. We can see that the data set is being initialized here, the num workers is being initialized, and then some other technical aspects are being initialized. And, oh, okay, so down here, this is the other thing that I wanted to show you. So I'm going to hit continue to drop us down to this particular breakpoint. So what this is a sampler, which is the thing or the object that actually gets the values for us. So if you can see here, there's two particular samplers that are relevant. So the first one is a random sampler, And you can see that this one is the sampler is initialized to be a random sampler if the shuffle value is true. And since we didn't shuffle, then we're not going to have a random sampler. What we are going to have instead is a sequential sampler. So that just means that we're going to run through the data set sequentially retrieving each value. All right, so we set our sampler, and then I think there's not much to talk about in here. So we're going to step out. And so that was the initialization of our data loader. Now we're ready to actually use the data loader. And this is where we're going to see our normalization process be in play. All right, so we're going to step in here, and the first thing that we're going to hit is the implementation of the iter function, because we've passed our data loader to the iterator built-in method, which in turn calls the iterator. So, or excuse me, the iter special double dunder iter inside of the data loader. So if you implement this particular method, it is what allows you to pass the data loader object to the iter function and allows you to iterate over the members that you have. So here, the kind of thing that I wanted to highlight to you is that we can see that two kind of things are in play here. Number one, we can get a single process data loader iter, or we can get a multi-processing data loader iter. And this is all dependent on whether or not we've specified num workers to be greater than 0. So if we want additional workers, then we would get this multi-processing data loader iter, and otherwise we're going to get the single process. And so to keep things simple, we're obviously in this example, we're going to work with the single process, so we didn't set any additional workers. So then that means that when we step, we are going to return a single process data loader iter. So, oh, whoops, I accidentally stepped into this, did not want to. Okay, so here we are, our iter or iterator has been returned from calling iter, and now we're ready to call next. So the next time we step in, we're going to be stepping into the call to next. Now the call to next lands us back in the data loader class on inside the next implementation, and this is just another special Python method that you have to implement whenever you want your object to be iterable. So you have to implement the iter function, and you have to implement the next function. So we're inside of next, and this is where we're going to get the next element that is available through the iterator. All right, so when we're speaking about elements coming from the data loader, these elements are batches. The data loader iterator returns to us batches of elements from the underlying data set. So let's go ahead and step into this next index method, because it's going to lead us to the use of something that we saw earlier, and that is the sampler. All right, so here we're inside of this next index call, and we can see the use of the sampler here. The sampler is being passed in to another next function. So we're kind of dealing with an inception of iterators here. We have the data loader is an iterator, and the sampler is also an iterator. So the sampler is going to be handling the indices that the data loader will ultimately use to pull the particular samples from the underlying data set. So let's step into this call, and then we can see where the indices are being collected inside of this batch list. So we can step down, and we can see that this is where our batch size comes into play. So our batch size is 1, so we're going to be iterating through the indices that have been made available by the sampler, and we're going to be collecting them. And then as soon as we reach this condition here, where the length of the collected indices is equal to the batch size, we're going to yield this particular batch of indices, which just means return. You may recall this is a sequential sampler, so it just iterates over the indices sequentially. If we were dealing with if we had enabled shuffling on this particular data loader, then we'd be dealing with a different type of sampler, one that sampled randomly. So we returned, And now we have our index, which in this case, our batch size is 1. And this is the first batch that we're pulling. So we're just getting the data element in the underlying data set that lives at index 0. So now with this index in hand, we're ready to go fetch the data. So we're going to call fetch and pass in the index. And now this is where the batch itself is constructed. What we get after we construct the batch is this data, which is a list, and then this collate function actually takes that data in list form and transforms it into a single tensor that is ultimately returned. So now we're inside of a file called fetch.py. We can see that this is a part of the torch.utils.data package. And essentially what's happening here is we're returning our data as a list, members in our data set for the indices that were passed in. So since we only passed in one index, we're only going to get one value back. But if we were working with multiple, if we were asking to get multiple values, then we would get multiple. So if our batch size was greater than 1, then this is where we would iterate over the data set, grabbing each additional value. All right, so I'm going to step into this call, and the specific call that we're stepping into is this right here. We're stepping into this data set index, and what this is, whenever we pass an index like this to a data set, the call is going to be intercepted, and we're going to be routed to a particular method that must be implemented for all PyTorch datasets, which is the getItem method. So let me just show you what I mean. We're going to step into this now, and here we are. So now we're in the MNIST class. You can see here, MNIST. The reason we're in the MNIST class is because the fashion MNIST dataset extends the MNIST class. So in other words, the getItem method is the same regardless of whether or not you're using MNIST or using fashion MNIST. All right, so we're ready to actually get our data. So here's where this happens. We go into an attribute of the class called data, and we pass in our index, and then we also do the same for targets. So target is another name for label, and that's why it's called targets here. So we're going to get our image and our label, or aka target. Pure list here. This is just this data is actually a tensor. So let's just take a look. I'm going to pull up the debug console, and I'm going to type in self.data, and I want to look at the shape of this tensor. Now this tensor is actually 60,000 by 28 by 28. So what that means is that this is the entire data set right here in memory. So before, whenever I was discussing, when we were looking at iterating through our data set to calculate the mean and standard deviation manually, I mentioned that the data set may be too large to actually load the whole thing in at once. And that's why we did the easy way and the hard way when we were calculating our mean and standard deviation. But in this case, we already have the data set loaded, which I wasn't aware of this until I did this debugging. I'm not sure if they changed it or not. I'm not sure if they changed this behavior or not. I can't remember like what it used to be if I ever looked in here. But basically what this means is that you can't use this class if you don't have enough memory to put all the whole data set into memory. So the other option is basically up here. This is where if we look inside the initialization or the class constructor for this class, we can see like what happens. So first the data gets downloaded, and then we can see here that the torch.load call calls the folder where all of the data lives. So that's here, and it basically just loads in a PyTorch pickle file. So PyTorch has pickled out this tensor, and it essentially just loads it all in at once. Now you may be wondering, well, what's the alternative? Well, the alternative is instead of loading all of the data in at once, you load in like file paths to the data. So then in the getItem, when we do, instead of just grabbing the data straight up from a tensor that's in memory, we would go at this time read from disk the file using instead of having the data here, the raw data, we would have like the data of the file path. So we'd be referencing the data, and at this time it would be read in. Now, obviously, that's going to be much slower, but it is what's required if the data set is massive. So at this point, we just have the image, and we're about to transform it. All right, so I'm going to step down, and here we are just getting the image from the NumPy array, which, yeah, doing this says doing this so that it is consistent with all of the data sets to return a PIL image. So we already know that this is a tensor because we see that. So this is a tensor, and so this call is kind of pointless, but they're being consistent. All right, I like consistency, but anyway. Okay, so now we definitely have two transforms, or we have one composition of two transforms. So let's just step into this. We know that we have one. We're going to step into self.transform. So now we are in the transforms.py file, which lives in Torch Vision. So Torch Vision transforms. This is where we are. And what we're going to do is we're in the call method. So we basically, when you call a transform, then you come into the implementation of what you want to happen when you call it. So we have two transforms. You can see them here. We have toTensor, and then we have normalized. So what this is saying is it's saying for each transform in the transforms composition or list, let's transform the image. All right, so we'll step down here. We'll step into this transform, and we can see that what this is calling the neural network functional API. It's calling the toTensor on this. Okay, so this is going to cause us to have to do a little bit more investigation. I'm not sure how we ended up with a PIL image because we were just dealing with a tensor, so I must have overlooked something. But let's just go ahead and assume, okay, we're going from a PIL image to a tensor. All right, so I didn't mean to step into this, so we're going to run over all this code until we're out. Our next transform is our normalized call. So this is where I wanted to actually show you how the normalization works in PyTorch. So we're going to step in, and just like with toTensor, whenever we did the transformation to a tensor, we got that method, or we ultimately ended up in the neural network functional package or functional API, where all of PyTorch's functional or functions live. So in this case with normalize, it's the same. You can see that we're passing the tensor, passing the mean, and the standard deviation. So let's step in here, and we can see that if we just step down, there's some pre-processing that's occurring, but ultimately we get down to where we're taking the tensor, and then what we're doing is we're saying subtract the mean, and then we're saying divide by the standard deviation. So this is exactly the process that we discussed in the video on normalization. We calculate the mean and standard deviation first, then for every pixel, we subtract the mean and we divide by the standard deviation. We're done. So at this point, we're ready to return our image and our label back out to the fetch function, which puts it in the data, and we keep running across. We'll eventually get back out. I think I accidentally just stepped into something here. Yeah, so now we're back out into our next data call. And then here's the next call in the data loader, and we're back out. So here we have our normalized image. So I'm going to just rerun this because I want to go back and see how we ended up with a PIL image. They used to have a PIL image, and then when I saw this again the second time when I was prepping for this video, I thought that it was just changed to, like, they changed the implementation, but it may be the case that I just overlooked something. So let's get out of Zen mode real quick. I'm going to rerun this program. And I'm going to kick back into Zen mode, and then I'm just going to run through here until we get into the get item call. So here's get item. Okay, so indeed the image is coming out of this data set, which is a tensor. All right, so let's just step over that. So image at this point is definitely a tensor. So we'll look at this shape just to see. Yeah. So this is 1. Okay, 28 by 28 from array. Oh, is this it? Ah, okay, I see. So this is where it just got transformed into a PIL image. Yeah, I thought that was weird before. Okay, so they take it from a tensor to a PIL image. You know, I bet they actually probably changed this from the last time I looked at it, because it definitely, I think, used to read the data off of disk. And if you do it that way, then you're going to have a PIL image here. So it's going to be a requirement to have that to tensor transform. But now in this case, well, yeah, I guess it's still a requirement. But if they didn't have this line, then you wouldn't have to do a transform on your dataset. You could just load your dataset right away and no transform is required. But in this case, since they do this, then you basically, you have to have a to tensor call inside of these transforms list. And I guess they're doing that, like they said here, to be consistent with other data sets. All right, so I hope that that helps you mainly with two things. First of all, understand the normalization process a little more deeply. And number two is to see kind of the benefits of messing around with debugging code. The best way to learn about code, and from my perspective and experience, is to actually spend a lot of time debugging it and trying to understand what's going on. And it's very easy, or it's a lot easier to understand what's going on with code when you can in real time inspect the data versus trying to have like print statements or something like that all through your code. So definitely, if you're not debugging at this point, set up the debugger and start learning how to do it. And if you didn't know, we're actually filming this video from here in Vietnam. And we have another channel where you can learn more about us and our travels, because we document all the places we go and many of the things that we do. So if you're interested in connecting with us in a new way, then go over and check out DEEPLIZARD vlog on YouTube. And also, if you haven't done so already, be sure to check out the DeepLizard HIVEMIND, where you can get exclusive perks and rewards. Thanks for contributing to collective intelligence. I'll see you in the next one.